Now we're going to move on to exponent laws. There is this first law here, this multiplication law. Now we're going to have, I don't know, 3, maybe 4 laws, and we're going to be jumbling all of them together and creating some really complex questions. But to start, we'll just do one law at a time. Now we have the multiplication law, and that says if you have, maybe I use green. If the bases are the same, only if the bases are the same, and you are multiplying, then the exponents can be added. So that's what we're going to do. If the bases are the same. So if you look at the first one, the bases are the same, and we are indeed multiplying. If that's the case, then you can add them. 5 plus 6 is 11. And that's all there is to this multiplication law. So here in B, -10 and -10, our bases are the same. So I'll put that, it needs to be in brackets because the negative is included. And then we can add the exponents. 25 plus 34. 25 and 34 get us 59. And that's it. We're not going to be going 7 to the power of 11. 7 times 7 times 7 times 7, 11 times. That's just absurd. That would take a long time. This is the neatest way to write it. Here we have 3 to the 9 times 3 to the 0. The bases are the same, so we can add 9 plus 0 is still 9. So that's what that simplifies to. Moving on to D. 2, 2, 2, 2. All the bases are the same, so I can add them. What's interesting here, you got to keep in mind, is that there's an 8 plus 5 plus 7. Sorry about that. 8 plus 5 plus 7, but there also is a 1 here. So when we don't write an exponent, that exponent is always going to be a 1. It's like a fraction. If I have 7, that is 7 over 1. And we never write it. We just write it as 7. In the same way, this is 7 to the power of 1. But again, we don't write it. We just leave it like that as just 7. But when we're multiplying, we're going to need to add them. So we kind of have to add this 1 back in. We need to do that so that we can go 8 plus 5, 8 plus 5 plus 1 plus 7. Now, I don't know what that is. 8 plus 6 is 14. 14 plus 7 is 21. So 2 to the power of 21. So moving on here, we have 3 times 3, 3. All the bases are the same, so we're going to be 3. And we're going to add these. So 6 plus 4 plus a -2. So 6 plus 4 is 10. 10 and a -2 is going to be an 8. 10 minus 2 is 8. So we have 3 to the power of 8. Now let's look at F. F, we need to make sure we group these correctly. Only the 5s can go together. So 5, and then we've got a 7 plus 10 plus 3, because all of these are multiplying, times, we've got an 8 and an 8, so that's multiplying as well, so we can add the 4 plus 9. So this looks like it's 5, 7, 10, 10 is 20, times 9 plus 4 is 13. So that is the simplest way to write that. Let's move on here. Now these are x's. So x, and they're all multiplying, so we can add the exponents. 2 plus 6 plus 5. 2 plus 6 is 8. 8 plus 5 is 13. Continuing on here. These are all a's, and it's all being multiplied. So we have 16 plus the 14 plus the -12. 16 plus 14 is 30. 30 take away 12 is going to be 18, I think. Moving on here. Okay, there's a lot of things going on here. Let's make sure we line them up correctly. The b's need to go together. Now this has a b to the power of 1, so we should probably add that. Then we've got the a's that can go together. And then the 5s that can go together. And don't forget that that 5 also has a 1. And I like to write this number first, then letters alphabetically. So I'm going to do the 5s first. 3 plus 1 is going to be 4. And then we're going to have the A's. 10 plus 9 is going to be 19. And then we have the B's. 7 plus 4 is 11. Plus another 1 is 12. And so that is our final answer. If you want, you can put the little time symbol in between, but it's not necessary. I don't think I had it in mind. So I'll zoom out. That is the first law, where if you're multiplying, then you can add the exponents as long as they're the same base. And you can see in some of these ones over here on the right, they add some different bases, so you need to make sure to organize. The bases are allowed to be numbers or letters.